Okay, if you go to DeSci World Twitter. One word, DeSci World, one word.
Let me try refreshing here.
Yo, how did you make your Twitter look like that?
Dark mode?
Oh, that's dark mode for you?
You changed the operating system?
Yeah.
So DeSci World is DeSci World. DeSci World, one word.
There we go.
There you go.
My dark mode is black. I'm jealous of that.
Oh, yeah, it does come up on my screen. I feel like it's a lot darker. That one's,
So it's like the cable or something.
yeah, interesting, hey?
That actually looks pretty good.
You just got to get the HDMI cable and work off the TV.
Yeah, and bend it until it makes the right color.
Yeah. Okay. Yeah, thanks everyone for hanging out, inviting me out here. My name's Lee. I'm a integrations engineer at UMA, and I'm gonna just give you a quick intro to UMA for some background context, and then I'll talk about our optimistic oracle and how that can be used, and then a governance tool we have called OSNAP. And please interrupt and ask questions or give comments throughout. Probably learn a bit more, and I'll have more fun that way too. So UMA's core product is our optimistic oracle, which is sometimes called the OO. And with that, you can verify and bring any publicly verifiable data on chain. Our TVS just crossed 1 billion. We've settled over 12,000 assertions on chain. UMA's core team is under the Risk Labs umbrella, and we've built some of our own products on top of the optimistic oracle. So outside teams can also build directly on the OO, but we've also built some of our own products. So one of the biggest ones being a Cross, which is like an intent-based EVM cross-chain bridge. So that's now like a sister company to us under Risk Labs. And then UMA also built OSNAP, which is allows for on-chain execution of snapshot votes and uses the optimistic oracle to verify those transactions before they're executed.
What was TVS?
Total value secured.
Secured. Okay.
Yes. And then we also have Oval, which is a brand new product we put out, which is actually not built on top of our OO, but it allows lending protocols to recapture OEV that's lost on liquidations. So really interesting topic, but we'll focus on the OO and OSNAP today. So the optimistic oracle will start here. So with the optimistic oracle, it's permissionless. Anyone can make an assertion to the oracle that this is a true fact. And assertions are made along with a bond. So the asserter needs to post a bond. Typically that's like, well, I think the minimum bond is around $500 in stablecoins. You can also use other currencies as well. And then there's a challenge period where that assertion is on the oracle and can be disputed. And if it goes undisputed, which happens about right now, like 98% of the time, the assertion is resolved as true and the asserter gets their bond back. And so that's the optimistic path, which makes this kind of like an optimistic verification system. But if it is disputed, disputes are resolved by UMA token stakers in like a commit, reveal, shelling point mechanism. So basically, UMA holders can choose to stake their UMA for rewards, but then they're slashed if they don't vote or vote incorrectly. And then after the token holders resolve the dispute, the winning party gets their bond back plus half of the other party's bond. So the bonding system incentivizes people to make honest assertions and also incentivizes people to watch for dishonest assertions so they can dispute them to earn money.
A question, what sort of assertions are possible with UMA?
Yeah, that is, I think, my next slide. One thing I just wanted to touch on is like the optimistic pattern the good part about it is that it's like cheap and efficient, that like 98% of the time we're not creating a vote for all UMA token stakers to have this vote, which takes more time and has a cost to all the voters, right? Like in time and effort. So it's cheap and efficient, and it's also like, it kind of sounds weird when you talk about it in crypto, like it's some new weird idea, but it's like replicated or all around us in the real world. Like when I sign an employment contract, we don't go to the judge and get it approved beforehand, and then when I quit, we take it back to the judge to verify that we both fulfilled our parts. It's like we just assume that both parties are gonna act faithfully, and if they don't, one of us takes it to the court system, and then we go through this expensive, time-consuming process to come down to like the actual truth, right? So data types. So because you can make any kind of like natural language assertion, it makes it like very wide ranging, but you can also like assert data as well. The key thing is that it can be publicly verified, because you need potential disputers to be able to review it. And if it is disputed, you need like UMA token holders to be able to look into this and come up with a resolution. It can be like more deterministic questions, like who won a sports game, the Celtics or the Lakers, or it can be like actually like subjective questions, because it is all like human interpretation. Of course, if you ask subjective questions, you're going to get subjective answers. But I think what the oracle generally resolves to is the most reasonable answer. So sometimes in subjective cases, yeah, like there is subjectivity in it, but it's like the most reasonable kind of mainstream answer to the question is generally how it resolves. But you can also write the rules in specific ways that like, we want this to be the resolution source, right?
And the data, because a question could have a long answer, right?
Yep.
If you have like a very complex question, is it a gas cost, or what's the like? How does the nature of the question change like the dynamics of the oracle, so to speak?
Yeah. So our older versions, we actually like allow people to ask questions to the oracle and then incentivize people to give answers. And that still is supported and can be used, but our most recent oracle uses like an assertion flow where there's never a question asked, rather an assertion is made. So you're saying this is a true fact based on these rules, right?
That's really cool, because, for example, in our case, we have, say, a lot of hashes of users signing some data, right? Can I post like a Merkle root of those hashes and have the oracle verify that they're all valid and correct?
Yep, for sure. Typically with those types of assertions, teams will provide a script so that disputers can easily and quickly like just verify it. But yeah, we have like technical data-driven assertions. But yeah, usually that's just like there's a public script provided along with it.
And also a public schema could be possible. Like they could verify data against the schema or something in a contract.
Yeah.
Interesting.
So yeah, we have examples of like real world data. So you can be like sports events. It could be the weather or the price of oil. And then another common use case is blockchain data, because obviously if you're using the oracle, you want the data available on a smart contract generally. And smart contracts care about blockchain data more than they generally care about weather. But not all blockchain data is available to smart contracts. Cross-chain data is not available to smart contracts, right? So you can verify data from any chain on one specific chain, right? You can verify metadata about smart contracts, like when was this contract deployed? Is this contract, is it like a rebasing token or not? All kinds of stuff like that. What compiler was used, whatever. You can do historical state as well. Like smart contracts can only access the current state of Ethereum. It can't access any history. So you can get like event-based data, or like how long has this address held this NFT. Those are the types of data that you can. I mean, it's really wide ranging. These are like some of the ideas.
So for example, if I want to just like a price feed where I'm updating the data all the time. If I want to have like a consistent pipeline of a specific verification with some assertions, but the route would change every so often. How is that set up in Loom? Is it like one different contract for each sort of claim, or can I have a claim that has to be revalidated, say every X amount of
It's there's only one Oracle contract, but you'd make separate claims.
separately?
And I keep meaning to add this, but one confusing point is when most people think of oracles, they think of like chain link price feeds, right?
Mhm.
That like update on some time period unless there's a deviation in price, right? So it's like a push oracle. It's fast and it's used in like really wide range type use cases, right? Our oracle is not a competitor to that. It's very different. You have to make an on-chain request or assertion on-chain to get a response back. And because of like this optimistic pattern where you need a challenge period, it adds like extra latency. So if you want like low latency price data that's like updating all the time, like we're not a great example, although you can set up price feeds for like real long tail data where like Chainlink's not going to set up like a price feed for like some brand new coin that has like no liquidity.
Right.
You can permissionlessly do that with us, but you're probably going to have like more latency, right?
Right. But it's interesting as a way to like offload a lot of compute into a claim.
Mhm.
Because if I have to prove, say, 100,000 hashes, I can have the optimistic oracle do that and just have the claim to those hashes along with the Merkle tree, so everyone knows they're true.
Yeah.
And they're there, so it's available.
Yeah. Yeah, and that's my next bullet point. That like one other advantage of it is you can do like off-chain calculation, basically, right? So if there's like calculation that's not possible on the EVM, or there's calculation that's like too gas intensive to run on smart contracts, you can like define rules that decide like how that calculation should be done, and then you can assert it to the oracle, and basically you're getting off-chain calculation, but getting like the verified results on-chain.
So after I do my claims, there's a period of time after which that data is assumed to be true because it could have been optimistically proven otherwise, like because they live on chain forever, basically.
Yes, but it's resolved after the challenge period. So the challenge period is like configurable, but it's like the assumption is that there's incentives to disputers, both in like disputers can earn the assertor's bond if they correctly dispute it. But there's also like often lots of use cases. There's like parties that have incentives outside of the bonding, right? To review this.
Right.
Like if it says an insurance protocol and I make a claim saying, hey, this smart contract got hacked, I deserve a payment. I'm an incentivized party to watch that. But or even like the platform itself is also incentivized to watch it as well, because you only need really like one honest disputer.
Right.
And the challenge period and bonds are configurable too, so you have to like think through it, and like that's obviously something that we support like integrations with, like is trying to think through how they should set up their bonding and their challenge periods and stuff like that.
And what's the average period nowadays?
The minimum is right now on like mainnets is like 2 hours. So if it's like very easy to say Polymarket uses that for like sports betting. It's like really easy to tell who won. There's like obvious finality after the game is over. That there's only like a 2 hour challenge period. It often like depends too. Some use cases they don't really have like a high value on latency, right? Like if it's like some kind of DeFi derivative that had a length of 1 to 2 years, and it's like doesn't really matter to them if they wait 2 hours for this to settle or 2 days for it to settle, right?
Is the price calculation depending on the time too? So if I have a low,
like the bond,
right.
Yeah, I mean you can figure it however you want. The higher bond, the higher incentive disputers have to watch this, right?
When I have a good friend named Vitalik, and he's into cyber attacks, and I can say, Vitalik, I need $40 billion. I want to challenge that thing. Then you can actually create 100 million accounts, each with a bonded value, and claim that he's right? This is what people asked me for the last 2 years about that concept. I'm wondering if that's
Sorry,
possible.
So you mean they buy UMA like an economic attack on the dispute resolution?
So there's an assertion on there's assertion to be disputed.
Yeah.
And you need to put more. You put money where your mouth is, right? So actually it's all money, monetary incentivized.
Yeah.
So the one who how I understand it is the one who has the most money can actually define on the oracle what's the real truth. You can challenge that, right?
Some other similar oracles use like escalation games where it's like it starts with a low bond, and then I say, oh no, that's not true. I'm going to put up a higher bond,
Exactly.
but then they can put up a higher bond. We don't have that kind of escalation system. When an assertion is made, whoever asserts it is to decide the bond value up like above a minimum bond value that UMA sets to prevent like spam. They set the bond value. They pay that bond as the asserter. If the dispute requires a bond of equal amount, and once there's been a dispute, it goes to the UMA token holders to resolve. There's no like escalating bonding.
But Vitalik still can buy a lot of UMA tokens, right?
Yes, you could still economically attack like the dispute resolution mechanism of UMA, right? So that if you buy 51% of the staked UMA and stake it.
And 51% is actually the threshold where you say, okay, all our holders, 51% vote against the dispute, they actually win, right? But no, it's distributed.
They can decide the result of the dispute, yeah.
Is it 51% of the token staked, or is there any kind of quadratic aspect to it?
No, it's just token weighting.
Token weighting. Yeah.
So it's 51% of the voting token staked. There are like pretty decent slashings to if you are staked but don't vote.
Right.
So there is like a decent voting turnout. And there are ways to like change how you handle the resolution by UMA. So if you want to be more conservative, and this is something we do with like OSNAP, if an assertion is disputed, the contract that relies on it will not act on the resolution. So basically, that assertion is basically thrown out, but UMA token holders still need to vote on it so that the bonds are distributed from the proposer to the disputer, and so that make sure that there's still penalties for people to do incorrect assertions. But if you have like concerns that like the value of the assertion you're making is pushing the bounds of like UMA's economic security, you can like not act on disputed assertions, but there'll still be resolution for settling bonds. But yeah.
The target contract that I'm writing that the oracle should control must, of course, obey the oracle, right? So every time, so I have to trust the oracle itself, the oracle contract, because it will call me back when something's
Yeah.
So
Yeah,
So after the dispute, after a period has finished, right?
After the challenge period, or if it's disputed after the dispute resolution period.
Okay. And also, it came to mind, what's the incentive for anyone to post a bond higher than the minimum? If I'm the bond like poster, don't I just want the minimum amount of security needed?
Typically, like it's not like random users come to the Oracle to make assertions. Usually it's like a DeFi platform or some kind of Web3 platform that wants to have this. And so if people want to make an assertion, it like goes through their smart contract and then to the Oracle. And so they, in their smart contract, they define how big the bond should be because their protocol is relying on the security of the Oracle. So they want to size the bond correctly, right?
I'm just wondering what correctly means. Like, what benefit do I get? Because in architecture, it would be like posting the same bond over and over and hoping we don't get slashed because we need it for the next bond, right? Because you have to keep making these proofs. How do I price the bond so that, like, what do I gain for getting more tokens? Is there like an incentive for putting a bigger bond?
For a higher bond, the higher than the benefit of having a higher bond is that disputers are more incentivized to watch for malicious proposals and dispute them, right?
Malicious being like
yeah. So if you have like a an address gated assertion on your platform where you say only we can make assertions to the Oracle, then it's not really that important because you have a trusted actor already.
Right.
But usually people make it permissionless, so anyone can make an assertion to your smart contract that goes to the Oracle, and then your smart contract is going to act from the result of that, right?
Right. I mean, but I'm more interested about like us as like providing these assertions mainly for offloading compute, right? So it's more about keeping the issuer trustworthy. So like we're saying, we have these hashes.
Yep.
Here's a list with a timestamp. Prove that we didn't lie. So like it's a pretty low barrier because like in theory the Merkle tree itself is provable. We just don't want to do the computation on chain.
Yeah.
So like we could post the bond always with a minimum amount of like collateral, because we know that the proof is only it can only be disproven by the hash proof. So like in our case, for example, it would be best to just use the minimum viable bond, right?
I think that would, like, if it's you have the script that makes it easy to dispute too. Like the other thing is like if it takes like a lot of work to review the assertion, then you should provide a higher bond too, because you have to like incentivize possible disputers to go through all that effort, right? Also, the bond value also defines like the risk that a malicious actor takes,
because you have to put the same amount.
Well, if they want to make a proposal with a malicious hash, they're risking their bond. That if someone catches them and says, "Oh, this is wrong, I'm going to dispute them," they're losing that amount of money, right? So like they have the possible outcome that it gets through, and they make whatever it takes to hack your protocol, but they're risking the bond, right?
So the dispute is just like a claim to the claim. You know, like it basically creates a new assertion that is saying with a bond, right? Saying that assertion is false. And if I get that one disputed, then he loses his bond to the second line disputer, right?
Well, there's only ever one asserter and disputer. I guess I'm thinking that a malicious user can make assertions, but we're going to gate it to a specific address.
I mean, we would be the only ones making the assertions.
Okay.
So we were just talking about who's disputing these assertions and why.
Yeah.
And they would have a script where because in our case, we're just saying, hey, you can prove that we're not putting in fake data.
Yeah.
And with that in mind, we could just use a basic bond because it's in our best interest to not lie. So all we want is for the ability to someone to disprove us if that came to pass.
Yeah. So then I think the primary benefit of having a larger bond would be it would provide more incentive for people to actually review the data you post. Like if you post a $1 bond, it's like no one's going to bother to run the script to possibly earn $1, right? If you do like $100,000, well then like it's economically worth it for people to review your assertion.
May I ask
Yep.
another practical thing? This is actually pretty excellent if you have what we just talked about, right? If you have an on-chain governance method on an L2, and you want to react on an L1 or another chain to that outcome, you can use that actually, and you have a 2 hours minimum period, which is really fast actually, right? So you can say, okay, the Oracle decided that there is a positive vote on, I don't know, optimism, that we should now spend $1,000 from this treasury to somebody else, right? And you can just wait for 2 hours for the cross-chain message to happen.
Yep.
Well, this is pretty great, right?
Yeah. Yeah. And I mean, a lot of like cross-chain stuff has like bespoke solutions for that. But the Oracle is very capable of doing that too. Like we have teams that like, they want a certain price feed on a certain chain, but it doesn't exist. And so you can like talk to oracles and like pay them to bring that price feed there. Or it's like, you know what, we're just going to use the OO to bring the price feed from Ethereum mainnet to whatever L2 we're working on. Right. So you can like permissionlessly and easily build like these cross-chain data passing basically. Yeah.
So can a contract ask a question or state an assertion? So
yeah, typically that's what happens, because then that contract will be set up to act on the result from the Oracle. Like it's never really that like some EOA makes a random assertion online on chain, because people are usually want to like make use of the Oracle result in a smart contract, and the way to do that is to like make the assertion through a smart contract. and you can still make it permissionless that anyone can hit that smart contract that makes the assertion, right? I have a slide later that shows that. Yeah.
Quick question. Are you familiar with TLS Notary?
No.
TLS Notary lets any website make an attestation or basically cryptographic sign its data. So,
Okay.
For example, PNC.com can act as an issuer that you logged in, have an account with them, and a certain balance, and make that possible to post on chain in the form of a ZK proof. So what's interesting there is every website can act as a notary for its own data, and you don't need to worry about external attestations on the data that's served from the site. You can trust that the site will most likely be working, unless something happens, will most likely be working as intended and serving data as long as its like private key isn't
Compromised.
Yeah.
Interesting. Yeah, that'd definitely be an interesting use case. We've seen some other suggested use cases like more like hackathon projects, but like protecting against like front end hacks where like DAOs make assertions that this is like a hash of our GitHub repository for the front end. And then they have like an extension. So it's a pretty cool idea to prevent like front end attacks. Yeah, I mean, that's kind of the thing with Oracle. Like there's super wide ranging use cases. Like I have some of the ones that we have right now, like prediction markets, like Polymarket and Floor. Polymarket is the main one right now, and they make like a ton of assertions to the Oracle. So it's been like a really good like stress test for the Oracle, and they really like push the boundaries with sometimes like subjective, hard to decide questions. It's not all easy, like who won the basketball game. And so that has been a great like training ground for the last few years for our Oracle. And we believe in like prediction markets too. We think like they have real value in determining truth. And then we also have like insurance markets like Cozy and Sherlock give like smart contract insurance. So that their questions would be like, has this smart contract been hacked? And so those insurance markets have like generally like a higher TVS, like they have more money at one point in time than like the prediction markets, but they make like, one assertion maybe a year, right? Where Polymarket is like constantly cycling through like value and making lots of assertions like in the thousands per year. We have like data verification integrations like Rated. So they have an Oracle that brings data from like the beacon chain and metadata about like validators onto Ethereum through our Oracle. We have like cross-chain examples like across like the bridge we built. So basically what they're doing is when a user wants to transfer tokens across different chains, they deposit tokens into escrow. And then there's like a decentralized network of relayers that are like competitively looking to fill them on their destination chain. So as soon as they see someone deposit, they can fill that user on their destination chain. They might carry some risk on finality depending on how quick they do it. And then later there's like a bundle of data that's asserted to the Oracle that verifies, okay, all these relayers filled user orders, and it does a bunch of like internal accounting. So it does like this like compute off chain. And then when that's verified, the relayers are all paid back after that like challenge period. We have like transaction verification, like Index Coop. When they rebalance their indexes, they wanted to like decentralize that process. So they have like a rule set. This is how like the target allocations for this index should work. Now anyone can propose new allocations, and the Oracle will verify that the transactions they proposed meet the rules set by index. And after that's resolved, there'll be a transaction against their smart contract. Will update their allocation targets. So that's like a really cool process where you can like DAOs or protocols can like decentralize and automate the upkeep they do on their contracts. And then we also have our governance tool, OSNAP, which we'll talk about in detail in a little bit. And so this is kind of like a smart contract flow of usually how assertions work. So I'll focus. Ooh, don't move around. Okay, I'll focus on the right-hand side, which is like our latest version of the Oracle. So in the top right, you'll see like that DApp smart contract. So they'll have it like pre-configured what kind of assertions they want to make to the Oracle. So say like an insurance contract, they'll say people can hit this contract, and that's going to make assertion on the Oracle saying the Aave smart contract was hacked, right? And so they'll define like the rules, how this should be verified, what kind of data sources they want to use, possibly stuff like that, what constitutes a hack. And so they'll assert that truth on the Oracle, and then we enter this like liveness period where anyone can dispute it, and that's done on like the UMA front end. So we have a front end for the Oracle. And then if it is disputed, we go through this like pessimistic path where we have UMA stakers vote to resolve it. And if not, we just go straight to settling it. And so then the assertion is settled on the Oracle, and then it calls like a callback function in your DApp smart contract that will react to the resolution. So if it was hacked, it would pay out all the users for their insurance. If not, it would do nothing, right? And we have some other callbacks too, that if you want to like have some kind of action after a dispute, so you can do stuff like that. And then we also have like bots that automate some of this like settling functions and stuff like that. Yeah, I think that's my last slide on the Oracle. And now that we understand how the Oracle works, we can understand how OSNAP works. But if there's any other questions on the OO before we move on. So OSNAP. Yeah. So just like for some context on like DAO governance and typically how they vote, like pre-OSNAP or without OSNAP, the typical ways where there's like off-chain voting, say on Snapshot, and then usually like a DAO would have a multi-sig that would execute it. So the pros of that is like it's gasless, very easy to set up, good UX on like Snapshot with off-chain voting. But the cons are it's centralized. Obviously, you're relying on like the multi-sig to follow the Snapshot vote. It's also like pretty opaque because usually there's not like transaction data that's actually included in the proposal. So so the multi-sig signers like are making up the transaction data after the fact too. There's like gas costs for the signers. It's also often like slow and painful to wrangle like a bunch of signers. And there's also like possibly signer liability too, that these signers might be liable for the actions of the DAO. A lot of people are like getting uncomfortable with that, and like lots of investment firms and stuff like that are deciding like not to vote and stuff like that. And then the other alternative is like on-chain voting with something like Tally or Aragon. And the pros of that, it's like decentralized, trustless, permissionless of Ethereum, all those characteristics. But the cons are there's like significant gas costs, which is like a cost to your users and also like discourages small voters from participating. It's often like more effort to set up, and it sometimes limits your voting strategy, like how you calculate the votes that voters have, their voting weight. And kind of oddly, like a lot of DAOs and even like big name DAOs, they often use like an off-chain temp check vote, or not even a temp check really, like an off-chain vote to decide what the DAO will do. And then they do an on-chain vote on Tally to gain the on-chain trustless execution. But they like I know Gitcoin even says in their docs, like no one should ever vote no on Tally. So really the decision is made on Snapshot. They're only using the Tally vote to have on-chain execution without a multi-sig. And then in comparison with OSNAP, you have off-chain voting with like decentralized and trustless on-chain verification and execution. So when you go through, like, you kind of get the pros of off-chain voting, and that is gasless, easy to set up, good UX, centralization. I put centralization with an asterisk because I do think with like very young DAOs, sometimes having some amount of centralization is actually a benefit. Eventually, you want to work that out and transition away from that, but it's kind of the idea that like startups need to move fast, and then maybe eventually they have an IPO and they become a publicly traded company, and at that point they become like more decentralized. But like same with DAOs, that like decentralization is good, but it also has like some drawbacks, especially in like early life cycle.
Is the centralization aspect there the fact that certain players can post votes? Is that what you mean?
So the centralization aspect is that OSNAP can also work alongside multi-sig. If you want, you can like remove that multi-sig if you want to like go full decentralization.
As an on-chain execution of the vote.
Yeah, so you can have an option that like you could have the multi-sig execute from the safe, or you could have and you could also have OSNAP on that safe for like decentralized execution.
Good. Can people stop a transaction from happening? So if I have the multisig, can I change, for example, the nonce of the transaction by going forward?
You could. So if you have the multi-sig on there, they still have like some ways to prevent OSNAP from functioning correctly.
So
Or you could remove the OSNAP module from the safe.
So a truly decentralized multisig would be one that maybe there's too many signers forever to get a vote, and only OSNAP can do it.
Well, what we've seen with like people that want to remove the multi-sig, they just like transfer ownership of the multi-sig to the 0 address.
Oh.
Some
But
uncontrolled
OSNAP
address.
Can still just operate.
Yeah, the safe will still function. That has some like drawbacks that we can probably better to get into later. But yeah, we'll talk about that like fallbacks. But yeah, so you get the pros of off-chain voting, but then you also get most of the pros of on-chain voting. So it's the execution is still like decentrally verified, and so in that way, it's like trustless, and it's half permissionless. So you're still reliant on Snapshot, which is not permissionless. I mean, I think they're good actors in the space, but if they decided to censor someone's vote or censor a space, that could become an issue. But the on-chain portion of OSNAP is on-chain as permissionless.
Could you do like a meta thing where speak on, right? You have 5 different voting providers, and you do the average of them as this OSNAP result.
Yeah, right now OSNAP only works with Snapshot, but you could definitely do something like that, like use other off-chain voting systems as well, and write that into your rules that like Snapshot proposals are valid, but also off-chain voting platform B is also useful. Yeah, so you get some of the pros of both. So I can run like a simple demo. So the prerequisites to using OSNAP are you have like a Snapshot space and you're using a safe, which are like 2 really commonly used platforms for DAOs. It's easy, requires like no code and like 2 minutes to set up. And then I'll show the other stuff in my little demo here. So this is just a test space I have on Snapshot.
Setting up the OSNAP module on safe is not exactly the simplest thing to do. I remember that.
No, you did it when we first launched. So we've since heard DAO's pain points and improved the experience.
And the Snapshot space requires an ENS name. Good luck explaining that.
Yes, it does require an ENS name. So under settings advanced, we now have like an OSNAP by UMA plugin. So you just add this plugin to your Snapshot settings. And then after you add a treasury, you can now just click this button to go straight to the safe OSNAP app. So you don't have to go through the Zodiac app, which is kind of like a harder UX.
Yeah.
Safe removed. Actually, I have a Polygon safe here, so I can hit this one. so straight from the snapshot settings, you go directly into the Safe OSNAP app where you can activate or deactivate it or change settings. So you basically can navigate just from this one snapshot settings page to get everything set up. And then when you go to create a new proposal, just like any other one, it's mostly the same. You can turn on OSNAP or leave it off. That's something that DAOs find like really helpful, is that it doesn't like, if you still want to do a vote that doesn't have on-chain execution, it still looks, you can turn off OSNAP. So like those proposals look exactly the same to voters, other than some of the added OSNAP parts. So let's say we turn on OSNAP. We will continue. Let's try this again. I'm going to show our transaction builder. Let me try and push this back. Fetching the snapshot block number, which you need to go to your voting power. Huh.
Polygon's down.
Yeah, I don't know.
I told you, don't use those.
I wonder, I think my snapshot voting is on Gorley. I wonder if snapshot removes support for Gorley now too. Let's see if I can do this quick. If not, I'll just leave it. Sorry about that.
Demos. Yeah.
But Gertie
Demos.
Gertie should be down by now, right?
It's going down.
Okay, let's get rid of this.
Down at the beginning of January,
Right.
so nobody should rely on Gertie anyway.
Yeah, it's tough because some of the dependencies like Safe and Zodiac aren't like
Exactly.
weren't on Sepolia yet.
Still
Okay.
alive.
I think this should work now. No, still. I just have a whitelist now. Don't even have. Oh yeah. Okay. So now on this OSNAP enable proposal, we are going to include the transaction data that will be executed after the proposal if it passes. So I'll just do this Polygon treasury. So we add a transaction, and then you can like easily send tokens. Just pick the asset, and then the to and the amount to send. You can also do the same for NFTs. You can do like raw transaction data, just putting in the address, the value, and the bytes. And you can do contract interactions as well. And I'll just grab. If you have like a verified address, it'll pull in the ABI and give you the arguments needed. So now you can see, okay, on this contract, these are the functions that are available, and then you can put in the arguments as well. So it's really easy to build this. And then we also just recently added Tenderly support. So you can, oh, whoops. Let's put in a valid address.
Could you do like an optimistic trading fund that trades on like whatever to propose?
Yeah, you could have like a DAO that has a fund that they manage through the snapshot votes.
What would happen? I mean, this is executed in some time in the future, right?
Yeah.
Now the simulation is great, but what's happening when that doesn't
Yeah,
work anymore?
there is a possibility that it may not be executed be able to be executed depending on like what kind of complicated transactions you're running.
Just
For sure.
reverse.
Yeah, so it wouldn't ever be able to be executed, basically. This is definitely very handy. Most things aren't like time dependent like that, but you definitely could come across that. And so then,
a Uniswap pool, right? There's a time limit.
yeah.
That could be already from it.
What's the fastest execution time you've managed, like from proposal to transaction?
Yeah, we generally encourage DAOs to use like 1 to 3 days as a challenge period because most DAO transactions aren't like high like time dependency. And in their settings, like they set the challenge period, and that would be used for like if there was a potential malicious proposal as well. So in that you want to be like conservative, right?
So it would like in the decentralized fund, they would be more interesting to do the index group thing and have people propose their weights to a pool rather than a swap. And you just let, because that's less time dependent, right?
Yeah. Yeah, and so now this is our proposal, and then voters can see the transaction data, and they can also see like the tenderly simulation as well. So it provides like very good transparency for voters. And then after the vote has, like the voting period has ended, and let's say it's like it's passed, and we've reached quorum. Then this transaction would be ready to be submitted to the Oracle to verify that like the transaction data that's submitted on chain for execution matches the transaction data on the snapshot API. And so what's submitted to the Oracle is the snapshot IPFS hash and the transaction data. And then the Oracle verifies that the transaction data submitted matches the snapshot proposal, and it also checks that the snapshot vote, the voting period matches the rules, and that quorum was met on that vote, and that 4 was like over 50%, so that the vote passed.
You should see that on the Yuma dashboard, right?
Yeah, you'd see it on the Oracle once it's sent to the Oracle.
That's cool. That's a lot of computation you're doing for the proving, but it's not on chain. Like it's a lot of verification going on.
Yeah, but it's very easy because like Snapshot has an API, right? So like we have bots that I'll get into that now. So like the on-chain portion, this is the flow. Like proposed transaction is sent to the Oracle, and it includes that, like I said, that IPFS hash, the transaction data, and of course a bond. Mm-hmm. And then the Oracle verifies quorum that was over 51%, and it verifies the transaction data matches. If there's no dispute, a transaction is sent to execute that transaction batch against the safe treasury. If there is a dispute, like I was talking about before, OSNAP will actually like ignore that transaction batch no matter how UMA token holders vote. Right. But UMA token holders will still vote to settle the bonds. And so then all these transactions, other than, well, I guess, yeah, all these transactions are permissionless, so anyone can do it. You're not dependent on UMA, but it's also like a pain point for DAOs. They have to remember to come back. Who's going to pay for the gas for it? Who's going to post the bond? Like that's kind of a pain point, right? Right. So we created bots for all those systems so that if you use our default settings, which is like a 2 WETH bond and a 2 to 3 day challenge period, we'll execute those transactions for us with our bot. And so then we'll also post the bond and we'll pay the gas to execute the transaction from your safe. Just because we're like, we run bots for other systems already and we're like confident in the system. And this verification is really easy to bot because it's like you're using the Snapshot API. So basically the DAO only needs to think to set up the proposal, and then everyone votes, and then after that, everything is automated, and the gas is paid for. And then just the verification on that's done through the Oracle. So first you have like the decentralized network of disputers that are watching these proposals, because there's already like tons of assertions going through the Oracle from like prediction markets and other other integrations, they're watching the proposal and they're looking to like earn that bond. So they're watching it. And then we also add like some extra layers of verification on any OSNAP proposal.
Mhm.
So we have our disputing bot. If we see an OSNAP assertion that is not valid, we'd automatically dispute it. And we also have like a verification team of like 3 human verifiers, so like UMA community members that review all proposals and then flag ones that should potentially be disputed.
And do you have any like distribution of UMA at any point in this verification pipeline, or is it the token has already been distributed and it's just the governance layer?
There's no UMA distributed in this. Like the bonds aren't in UMA; they can be in whatever. Typically, we use like WETH or USDC, or typically integrators use that. But there are other options. Yeah, so there's no requirement for like integrations to hold UMA or anything. Or
But it isn't, and how is UMA distributed? Like, where does it come from? Or is it already distributed in liquid?
yeah, it's already distributed in liquid, and there is like inflationary rewards that go to stakers. So we want UMA to be staked and uses for voting. That's like the purpose of the token. So we have inflation rewards to those folks. So anyone that's not staking their UMA is basically getting like, what's the word? Diluted
Right.
away, right?
Oh, right. Isn't it interesting to like pay out UMA to bonds that are successful, in the sense that it's like trusted data, so you want the person to have some incentive to keep posting, or it's just not interesting. That
Yeah, I think
paying in UMA, right? It would be cool if I post my bond in UMA, that I get my UMA +1, so I can keep. I may even put bigger and bigger bonds because I'm getting some incentive for doing it in a trusted.
yeah. I mean, you could think of it like an airdrop to people that are like successfully disputing. It's like these are people that know how the system works and are like using it, so they're probably like good voters. So you could like use that as like a airdrop mechanism. We want the token that's used for the bonds to be like the lowest barrier to entry possible. So that's why we encourage people to use like wrapped ETH or like USDC rather than like their own protocol token.
Right.
Because then you're like, if you're just lowering the barrier of entry for people to dispute. Yeah.
Because it's more desirable for people to get the dispute.
But just they already have that token. Most people are happy to hold Ether rather than like some random protocol token. But you can use whatever you want. I mean, like what I said before, our bots only support like the default rule set. So if you want to use like your own token for bonds,
To
then
make run bots.
yeah,
Code for bots.
yeah, it's public. And that's my last point here too, is that like we have like public code that you can set up your notifications, so that if your own DAO like wants to add their own extra layer of like review and verification, you can like anytime there's a proposal, you can make a post in a Discord channel so that the DAO sees it and they can all review it as well. Yeah. Yeah, the last thing I just think I'd talk about some of the examples of people using it and how they're using it. Like Gitcoin and has a grant program that's likely going to use OSNAP for distributing those grants. Arbitrum, LTIP as well is going to be using OSNAP to distribute grants. So those are like organizations that use on-chain voting for like high security, but like their grant program, they want it everyone to be able to vote. They want it to like move a little quicker. So they see some of the benefits of off-chain voting, and so they're using OSNAP. CowDAO has OSNAP on their treasury with no like on-chain voting. And they have executed like an $8 million transaction that went through OSNAP.
With that, you mean cow swap?
Yeah, the DAO behind CowSwap. Across updated their staking reward system through OSNAP, so like more complicated transactions. We've had one malicious transaction against like the Shapeshift DAO that was disputed within like 20 minutes, even though it had like a 3-day challenge period. So that malicious asserter lost their bond. And then like Epoch Island uses OSNAP to like vote on elders and mint and transfer NFTs to them right away. And they've basically used like OSNAP for all their like contract interactions and even deployments and airdrops and stuff like that.
Nice.
Yeah.
Cool.
Yeah. That's the end of. Yeah. Any more questions or? Yeah. Thank you.
I have a question.
Yeah.
What sort of what? What sort of it says permissionless access to the OSNAP protocol, right? But
Yeah.
when it comes to the optimistic governance, the optimistic oracle, that is directly related to UMA statements, right? The whole thing is governed really. The dispute resolution is governed by UMA statements.
Dispute resolution, yeah. It's still permissionless to make assertions.
Sure, but
Yes.
the resolution of those assertions, right? So, is there a way to have the same mechanism but disputed by your own board of?
Can you like whitelist disputers?
Not even whitelist, but like not even using the UMA token staking mechanism for.
Oh, for resolving disputes.
Bring
Yeah.
your own legislation.
Yeah,
Yes.
yeah. Yeah, I think we were talking about that, right? Like
Right.
we have a contract called escalation managers, which hasn't really been used before, but we did like have it audited and like it's in our docs for a few years. And with that, you can use like other resolution sources to resolve disputes.
Could you use the exact same mechanism but replace the UMA token with your own token? In
Yeah.
terms of staking to provide.
Yep.
Okay, and that's something that UMA supports.
We don't provide like a front end for that or like smart contracts for that. I mean, you could fork our smart contracts if you wanted and build your own front end for it, I guess, is what you'd have to do.
That's certainly a hard thing to do. So this will take a while.
Yeah.
You have to have the crowd behind you to build that thing up.
Yeah, you have to have the legislation there.
Yeah. And I mean, the other thing is like often you'd have a lower, well, depending on the market cap of your token and the distribution of it, you might have like lower economic security.
Right. Sure.
Yeah.
Is there any protocol fee?
No, we don't currently have any fees.
So all the dispute resolvers are actually incentivized by getting a share of the fairly bonds, right?
Yes.
So they will get something for saying that was bad.
And the protocol UMA is incentivized by the fact that you have to stake the UMA token to be a part of that ecosystem, and therefore the token price go up, and therefore seniorage and treasury go up.
Yeah, I mean, the dispute
Yeah.
mechanism. We want to incentivize UMA token holders to vote to up our economic security. So that's why we have like those like inflationary rewards. Like it's like 30% APR right now if you stake your UMA, and you can get a little bit on top of that better if you vote consistently and correctly.
The bonuses.
Yeah.
Great.
Yeah.
Cool. Thank you.
Yeah. Thanks for having me.
Great. 7:30.
7:30?